Alright, we got a series and sequences problem for the May 2011 paper 1, problem 11. And they're telling us that the 7th term of a geometric, okay, there's a key word, I'm going to underline that, geometric sequence is 108, and the 8th term is 36. And they want us to find the common ratio. Well, we remember that in a geometric sequence, we have the any term, the nth term, I use a's instead of u's, the any term is equal to the first term times the rate, or ratio, to the power of n minus 1. And we also know that to find the rate, we can we can divide any term by its previous term to find the rate, the ratio. So the ratio here is going to be equal to the 8th term, which is 36, divided by the 7th term, which is 108. And so we know that our common ratio for this problem is equal to 1/3. Then it says that I need to find the first term. Well, I know that, we can use either one. Let's use the 8th term. So the 8th term is 36. So 36 is equal to the first term. This is part B. Let me label that. The first term times the common ratio of 1/3, and 36 was the 8th term, so I'm going to raise that to the power of 8 minus 1, which is 7. So that means that when I do this calculation, 36 divided by, and I've got 1/3 to the power of 7 is equal to the first term, and the first term is equal to 78,732. I like that problem. Alright, then it says the sum of the first k terms in the sequence is 118,096, and I need to find how many terms that is. So let's see how we're going to do this calculation. Well, let's see. I need a formula for finding a sum. And I've got the sum of the first n terms is equal to the first term, so I'll write a sub 1, times 1 minus the rate to the power of n, all divided by 1 minus the rate. So we can just do some substituting now. So we're going to find the, I guess we know the sum. So 118,096 is equal to the first term. Well, I know that. That's 78,732 times 1 minus 1/3 to the k. So I'm going to take 1/3 to the k. That's what I'm solving for, or n. Is that confusing, n or k? All over 1 minus 1/3. So we are going to calculate that, let's see, r is equal to, or I'm sorry, k is equal to 10. Now, I'm looking at the answer key here, that's why I was umming, and they're telling me that there are a couple different ways I can do this. I could graph the right-hand side and the left-hand side of this equation and find where they intersect. Or I could, what else are they doing here? They're adding up, they're adding up all the terms until they get to 118,000 and figuring out, so they're actually having you calculate the first 10 terms and seeing that that adds up to 118,096. So if you know how to use logarithms, that would be another way you could solve this problem. That's probably how I would solve it. So you can do it algebraically. You could just start adding up terms till you get to 118,000, just keep multiplying by 1/3, or you could graph it and find the intersection. Any of those would work.